on Friday when Mrs. Fox is in here teaching it, because I know she can handle this stuff pretty well, is that really when it comes down to surface area and volume of prisms, it all goes back to the base. And I mean, there are two things you got to worry about, the base and the height with prisms. Prisms are actually way easier than pyramids. We'll do pyramids second half of the unit. First half is all about prisms pretty much. And what it comes down to, like I said, is the base. And this is where the giant geosolids come into play. Okay. You get to see them. You get to hold them, just don't break them. Okay. Hold on. Boxes. Boxes upside down. Fail. Box fail here. There we go. All right. When it comes to prisms, basically all these things are prisms. Okay? We got a triangle-based prism. A cylinder technically is not a prism, but for all intents and purposes, it's got a hexagon-based one. All right? This one's a cube, a square base, a rectangular-based one. All right? Why is that a cube but not a prism? It is a prism. Cubangular prism. It's just one. So if you guys want to like look at them, see its solid, pass them around, you can touch them. There's nothing really that special, but people get all excited. It's like, ooh, I get to hold it. No! Just don't break it. Just don't break it. That's all I ask. Okay? So, what I want you to notice is that the sides are always rectangles. All right? Whether it's a rectangular base or a hexagon base, or even in the case of a cylinder, if we if we have a cylinder and we open it up, what shape are the sides? It's a rectangle, okay? It works into a rectangle. Yes, it's blue when you look through it because it's got a blue base. For volume, you can actually put water in it for volume experiments. Yeah, let's not put anything in them right now because it's really hard to get it out. So, no. Okay. So the sides are always rectangles. It's the bases that's not rectangular side. Now, in the case of a rectangular prism, any side can be the base. Usually we use the bottom. But we have to realize, so if we have a hexagon prism or something like that, or a cylinder, that whatever's in the bottom might not be the base. It could be the hexagon or the triangle or whatever else. Okay? All right, guys. Hey. That's great. Okay. I'm a Smurf. I've been called worse. I'd say it, but I'm being podcast. Okay. So, anyway, so things we're going to be concerned about. We're going to be concerned very much about the base, the perimeter of the base, the area of the base, and then the height is the distance between the bases. So if I look at this, rectangular prisms are the easiest ones to work with. So if I look at a rectangular prism like I have here, I've got my bases highlighted in red and pink. Yeah? You can't wait 10 minutes? Goodness sake. Come on, people. Not exactly, no. All right. Why don't you pass those back up? They're getting to be a bit of a distraction. So. All right. So, because the base is, we're going to call this side down here on the bottom. First thing I'm interested in is the perimeter of the base. And here's where this stuff is not hard, but you have to be kind of precise. So the perimeter of that base, 10, 4, 10, and 4 gives me a total of 28 centimeters. Now, everything we do in class is going to be laid out this way. Everything you do on every quiz and test is going to be laid out this way. This is the way the problems are going to appear on the quiz and the test. Where you're going to get a picture and you're going to find these things. And it's the same idea. So you're going to get used to this format. What I would ask that you do is when you're doing your homework, when you're doing your homework, that you kind of lay it out this way too. It's a very organized way of doing it. All right, that's enough. All All right. That you lay it out, like I can't carry them all at once, that you lay it out this way. Perimeter of the base, base area. I mean, you don't have to do it in this order, but what this does is it organizes the information that you need to know. I know. And the key to doing well with this stuff is to keep yourself organized, because it's not hard. But if it's organized, it's pretty easy to work with. There are only a couple formulas that you have to remember. Also, just so you know, every quiz and test in this chapter, actually there's one quiz and one test, but both times you are going to start that quiz or test with a matching section that has the formulas. And the way it works is you do the matching page first, you bring it back to me, I correct it and write in and correct any errors that you've made. And essentially that then serves as a formula sheet for your quiz. So you really don't have to memorize so much as you have to be able to match the formulas, and even if you make a mistake there, you still get them corrected and sent back to you, so you should always have the correct formulas with you. The height of the prism, again, has to be the distance between the bases. What would the height be in this case? 6 centimeters. Okay? Make sure your unit's in there. Next is capital B. Capital B stands for base area.
It's 40 cm.
Okay, 40 centimeters squared. And here's now where we get into the interesting ones. The lateral area. The lateral area is the area of the sides. I mean, in 7th grade or so, you like folded out nets, remember, of three-dimensional shapes. You unfolded them and drew the net and counted the squares and all that sort of thing.
I don't remember that.
Okay.
We can look what you did.
Okay. Well, that's what we're talking about here. Is just the area of just the sides, the lateral area. The lateral area for any prism is found by the formula perimeter of the base times the height. Because it's a rectangle, it's like base times height. So that's why we organize this information. Really, once I have these three things, the rest of these all just come from that information. So I take the perimeter of the base, which is 28, times the height, which is 6. That'd be 120 and 48, or 168 centimeters squared. That's all the sides put together. Now I have to find the lateral area, or the total area. The total area is the lateral area plus 2 bases. Why? Because the top and the bottom are the same, right? There are 2 bases. So I take the lateral area plus base plus another base, that'd be 248 centimeters squared. And finally, and that's what you did on Friday, was finding the surface area. That's the total surface area. I often refer to that as a TA, total area, but it's also referred to in the book as the total surface area. Finally, the volume. Volume just uses the same information. We just add one more little formula to it. Volume is simply base area times the height. Instead of the perimeter of the base times the height, it's the base area times the height. But now when I look at this, base area is 40 centimeters squared times the height of 6 centimeters. Now 40 times 6 is easy, that's 240. But I take centimeters squared times centimeters, I'm going to wind up with centimeters cubed, yeah. Because volume is measured in centimeters or meters or inches or whatever, cubed. Cubic units. Because that's volume. Volume is units cubed. Because an area times a length. So you get a unit squared times unit gives you units cubed. But really, that's it. That's all that's new today is base area times height for volume. You've already calculated the base area. We spent the entire last chapter going over how to calculate the area of something. Finding the height, we had to find the height to find the lateral area and total area, which we did on Friday. So adding volume to the mix here is a really very tiny little addition. Just one little itty-bitty formula. And again, it just uses numbers that we already had worked with. So that's what we're doing today is we're adding volume to the mix, and it's base area times height for a prism. And we're focusing solely on prisms for this first quiz. Second half, when we work with pyramids, it's more complicated. Pyramids are definitely more complicated than prisms. Prisms are pretty simple. A cylinder is, for all intents and purposes, a prism. The book does give you separate formulas for cylinders. I do not use separate formulas. I use the same formulas because I figure you know the perimeter of the base is the circumference of the circle. Okay? You know that the area of the base is pi times the radius squared. So same formulas apply. What's the perimeter of the base? 8 times pi. So I just say 8 pi inches. Perimeter is a length measurement, no inches squared, just inches. What's the height of this prism? 12 inches. It's the distance between the bases. Again, it's a length measure, no inches squared. Base area.
16 pi. 4 times 4
Okay. Pi r squared, so 6, whoops.
It's 116
inches squared. The lateral area, again, we just go back to our formula. It's the same formula as before. It's the perimeter of the base times the height. Well, I have the perimeter of the base. I have the height. That's why we're using this format, because it lays out everything I need to know.
96.
So 8 pi times 12 is going to be 96 inches squared. The total area is the lateral area plus 2 bases. Well, that'd be 32 pi plus 96 pi is 128 pi. And again, it's still inches squared because it's an area. And the volume is just the base area times the height. Base area is 16 pi, height was 12. 16 times 12 is 144 plus 48, 192 pi. Inches. Now, what a lot of people do on these problems, on the test and the quiz, is they break the units in right away. Before they even start doing the problems, they don't forget their units. They go, oh, inches, 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 area, inches squared, area, inches squared, area, inches squared, volume, inches cubed. And they just write all those areas in before they even do the numbers, so they don't forget. It's a pretty good idea. Because, like, you get a half point for each unit being correct. So it's like easy points. Sometimes you get more complicated shapes. It doesn't matter because the formula doesn't change, really. All right? I could do it by I could do essentially the same thing. I could find the perimeter of my base. My base, by the way, is going to be this front side here, isn't it? Again, do not confuse base with bottom. It's still essentially a prism. Perimeter of my base would be 15 plus 3, so 18 plus 10, 28, plus 3 more, 31. This is going to be 5 coming across here because you already used up 10 here. So where was that? 31, 36. This is 6 more down here, so 42. Okay. The height is still the distance between the bases. This time my bases are my front and my back, not my bottom. So my height's just 5 centimeters. Base area, now this is a little tricky, but we can get this. To find the base area, I'm going to simply divide this for a second and add them up. I'm going to put this little thing in here. Say, okay, what's the area of this rectangle and what's the area of this rectangle? Okay, well, this rectangle is 5 centimeters by 6 centimeters, so that's 30, right? And this rectangle is going to be 10 centimeters by 3 centimeters, so that's also 30 centimeters squared. So my base area is 60 centimeters squared. And we're golden. To find the rest now, the lateral area is the perimeter of the base times the height. 42 times 5, that'd be 210. The total surface area is the lateral area plus 2 bases, so 210 plus 120 would be 330. And the volume is the base area times the height, 60 times 5 would be 300 centimeters cubed. As long as we lay it out step by step, it's really easy stuff. As long as we can identify the correct base. In this case, we had to recognize that the front end of that step shape was a base. A little more complicated, but in this case, let's not worry about the surface area. That would be a very complicated problem. Let's just do the volume. So I don't have to worry about perimeter. All I need is base area times height for both of them, don't I? In this case, let's use the square here as my base, because that's a nice square. So that base area is going to be 36 meters squared. The height is 12 meters. So my volume of just the prism on the bottom, okay, skipping school. So 36 times 12, sorry, is 432. Or it's meters cubed. Here, what's the radius of this base? I do have to figure that out. It's the same, the diameter is all the way across. So the radius is going to be, what's it going to be? No, 3. Half the side of the square, 3. So my base area, that shows up a little better. So my base area is the circle, is the base. So my base area there is 9 pi. The height is 10 meters. So the volume is 90 pi meters cubed. So the combined volume will be 432 plus 90 pi meters squared, meters cubed, excuse me. We're almost always going to leave things in terms of pi here. Almost always. Just because it's easier, I don't have to multiply 3.14. Okay? Always an interesting question. If I take an 8.5 by 11 sheet of paper, and I wrap it this way, I get a cylinder, right? Essentially. And if I do it this way, I also get a cylinder. Which one has more volume, or are they the same? Okay. Most people say it's the same. What they have the same, what do they really have the same? They have the same lateral area, don't they? Okay. Which one actually has more volume? Why? Why? Because the volume is a function of the square of the radius times the height. Those are two variables, right? Which one has the bigger radius? This one does. This has a larger radius. Now, it's actually pretty complicated math just to figure out the radius and stuff here, because you know the circumference. Instead of that, you have to work it backwards to find the radius. But you could do that. But since it's pi r squared for the base area, smaller radius. Now, when you buy cans of like Monster and stuff like that, what shape do the cans tend to take? The taller, skinnier one, don't they? Why? Because it's psychological. You go to the store, you look, you see that tall can, you think, wow, a lot of stuff in there.
Not really. The Mega Monsters that are like that big around.
Yeah.
And like that tall.
But in general, you know, I mean, when I go to the store and I see energy drinks, they tend to be in cans that look more like this one over here. Because like I said, the psychology of it. You look at that can, you see a tall can, you think more stuff. Okay? Basically, yeah.
Monsters so expensive.
Okay? So all I'm saying is that understanding volume can help you be better consumer products. Helps you understand to look. Don't just look at the height of the can. Look at the volume. It says right in the can, 12 ounces or 16 ounces or 24 ounces or whatever it is. Look at that. Don't look at how tall the can is, because now you know that that changes. All right, you've got the assignment to work on. That's really all we needed to get through. It's basic instruction. Again, our key formulas. Yeah, pretty much. Lateral area is perimeter of the base times the height. Total area is lateral area plus 2 bases. Volume equals base area times height. Those are my key formulas here for this. You probably want to know those. And again, these apply to, for how they apply to prisms. For pyramids, we will have different formulas for the same types of measurements. But our quiz here only goes through prisms. And when we look at our schedule right now, you can see we have K1 already scheduled for Wednesday. Tomorrow's a review day, and we're K1 already on Wednesday. That's our final benchmark, by the way, of the year.
We have an actual K test.
We have a K test. We won't have a K2 benchmark. We had to cut that out because of time. Okay? So that's our final quiz of the year. By the way, anyone who had anything from Unit I still sitting in the test center, that's been pulled now because their deadline for I retakes was last week.